Good morning, students. I hope you have understood Boyle's law and Boyle's law equation P1 V1 equals to P2 V2 when the temperature is kept constant. Today we are going to start with Charles' law. How did he define? Pressure remaining constant, the volume of a given mass of a dry gas increases or decreases by 1 upon 273 of its volume at 0 degrees Celsius for each 1 degree increase or decrease in temperature respectively. But you can also define Charles' law this way. Charles' law may be stated as volume of a given mass of a dry gas is directly proportional to its absolute temperature. That means you have to convert it into Kelvin. If the pressure remains constant. You have studied in Boyle's law the temperature was kept constant, but in Charles' law it is the pressure that is being kept constant. And the temperature, it's measured in Kelvin scale. That means you're going to convert Celsius into Kelvin when you're working out a numerical. Now, let us work out how you derive the expression V1 by T1 equals to V2 by T2, which we call Charles' law equation. Let a gas occupy V1 centimeter cube. V1 is the volume, initial volume, at T1, initial temperature, and V2 centimeter cube and T2, so final volume and final temperature. Then by Charles' law, you know that volume varies directly as the temperature. Temperature is measured in Kelvin scale. Or V1 equals to K T1, where K is a constant. So you can write the expression V1 by T1 equals to K, which is a constant. And V2 varies directly as T2. Or V2 by T2 equals to K. So when I combine it, I get V1 by T1 equals to V2 by T2, which is equal to K, or constant. And this is happening at a constant pressure. So the Charles law equation is initial volume V1 divided by initial temperature T1 equals to final volume divided by final temperature. So V1 by T1 equals to V2 by T2, and the temperature is taken in Kelvin. Now, according to this equation, if the temperature is doubled, the volume would also be doubled. Is that clear? Now, the second point is, if it is reduced by half, the volume would also be reduced by half, because you know very well that volume varies directly as is temperature. Now let us take a look at the graphical representation of Charles' law. This vertical axis and this is the horizontal axis. Volume is measured here in ml and the temperature in Celsius. On the right hand side it is positive, on the left hand side it is negative. Now when you plot the graph, you see that the temperature is minus 273 degrees Celsius. So this is the graphical representation of Charles' law. Now let us work out a numerical based on Charles' law. You have learned that V1 by T1 equals to V2 by T2 when the pressure is kept constant. And before solving a numerical, if the temperature is given in Celsius, you're going to convert it into Kelvin. A gas occupies 3 liters at 0 degree Celsius. What volume will it occupy at minus 20 degrees Celsius? Pressure remaining constant. Read the question twice, thrice to get a clear picture as to how I have to solve it. So, the initial volume is 3 liters, so I write here V1 equals to 3 liters. And the initial temperature is 0 degrees Celsius, so I have written T1 equals to 0 degrees Celsius. Now, I have added 273. Why? I am going to convert it into Kelvin. Is that okay? Now, what volume will it occupy? That means I have to calculate the volume V2. So I put a question mark. At the temperatures given, final temperature is minus 20 degree Celsius. Therefore, T2 equals to minus 20 degrees Celsius. I converted into Kelvin. So I have added plus 273. How much do I get? 253 Kelvin. According to Charle's law equation, V1 by T1 equals to V2 by T2. Now I will substitute the values. So 3 upon 273 equals to V2 upon 253. Cross multiply, you get V2 into 273 equals to 3 into 253. Therefore, V2 equals to 2 into 253 divided by 273. It works out to be 2.78 liters. Therefore, the final volume of the gas equals to 2.78 liters. So please practice these numericals on your own, and there are a number of worked out examples given in your textbook. Kindly go through it, and then you may attempt the questions given in the assignment. Thank you.